This is the Physics 2211 Lab 5 by Jackson Green Quorum. The purpose of this lab was to design my own experiment in order to test the ideas of physics that I've learned throughout this semester. I chose the conservation of momentum principle with an elastic collision in the form of two dry erase markers colliding with each other. For this experiment, I used Tracker and GlowScript to compare the real-life versus idealized versions of this incidence. Once I obtained the x and y data over time t from Tracker, I translated the initial velocity, mass, and other components necessary into code so that GlowScript would give me an outcome similar to Tracker. For this setup, you can see on the left, I have a meter stick laid out in Tracker, and I have the two dry erase markers at a set distance away from each other. To your right, you can see that the code that me and one of the physics TAs helped type up for this experiment. For the outcome, here's the tracker, mass A being the marker to the left over time, and then as soon as I begin the movement, its velocity shoots up, and then as it experiences friction, goes down until it collides with the other dry erase marker and goes to zero. And you'll see at the very similar time, when mass A begins to decline, you'll see that mass B begins, thus indicating a collision. In GlowScript, you'll see a very similar thing. You'll see that GlowScript mass 1 starts very high and goes down with friction, and then it plummets. But at that same time, GlowScript mass 2 begins and then slowly decays due to friction. So for these equations, I use the velocity update, the position update, and the force of friction, where the normal force is equal to mass times gravity, and then the conservation of momentum, m1v1 plus m2v2, is equal to m1v3 plus m2v4. So what does this mean? Well, from my model system, is the collision observed elastic, inelastic, maximally elastic? So this outcome is elastic. It means that one object hit the other and they both have a new velocity. So what if this collision was maximally inelastic? How would this affect the outcome and which equation would be utilized? So if this collision was maximally inelastic, that means that the two masses would have stuck together at the end, and it means that a variation of the equation m1v1 plus m2v2 would actually equal m3v final. So in conclusion, we saw that the GlowScript and Tracker similarities were very close. I mean, there was little discrepancy. And we can see collision in real-world scenarios such as car crashes and other situations. Thank you for your time.